As mentioned in the first course section, Go is a statically typed language, so types are important in Go. And types refers to the types of values, because every value in your Go programs is of a specific type. And when storing values in variables, as we're doing it here, you can see the type of a value if you hover over the variable that stores it. And it's then here where you can see that type that was stored. For example, investment amount is of type int. So this value here is of type int. And int simply stands for integer, which describes a number that has no decimal places, no fractions. On the other hand, expected return rate is of type float64, which is a number with decimal places. As you can clearly see here, this number has a decimal separator here. And these types matter, for example, in the calculation we have down here, because you can't just mix and match those types as we're doing it here. That I'm using investment amount, which is of type integer, in a calculation where I then also use this float64 type. Now, one possible solution here is to convert this integer to a float when we need to use it in that calculation. And this can be achieved by using float64 like a function built into Go, and wrapping it around investment amount. As you can see here now, the error now went away. Because this conversion function, which again is built into Go, converts this integer to such a float64 value for this calculation. So the variable still contains the integer, but for this calculation, it's converted to such a float value. It still, of course, is 1000, but in this calculation, it's now 1000.0, you could say. So it's treated as a floating point number. And that's a requirement by Go. Now I'll show you an alternative solution in the next lectures, but for the moment let's stick to this solution here. However, we're not done with this calculation yet, because at the moment I'm just multiplying my investment amount with 1 plus the expected return rate. But as I mentioned before, the formula is that we must take this here to the power of the years over which we want to hold that investment. Now in Go, unlike in some other languages, there is no built-in power of operator. But there is a package in the standard library that helps us here. It's the moth package. So we have to import moth here to use that package. And then we can use it down here in our calculation to access moth.pow for power. And then we have to pass two values to this POW function here, as you can also see if you hover over it. Here you see the general definition of that function, and you, for example, see here between those parentheses that it needs two input values. Now the first value that should be inserted here is the value that should be taken to the power of something. In this case, 1 plus the expected rate of return divided by 100. And we can now get rid of this pair of parentheses since we're now inside this list of arguments here anyways. Then, separated by a comma, we have to specify the second input, the exponent here in this case. And that should be years for this function. Now, as you see, I'm getting an error here because years is actually an int, and this function here, if you hover over it, actually wants a float64 value. So again, one solution here is to convert this int to such a float64 value by wrapping it with float64. And with that, it's not just the error that goes away, but instead we now also finished our formula here. This is the formula we can execute here in Go to calculate the future value of our investment. And this future value is then stored in this future value variable, which is inferred to be of type float64 by Go, because we're only using float64 values and operations in here. Therefore now, as a last and final step, we might want to output that future value.